Module 2, Modeling a Problem. In this module, we are going to revisit the problems we did in the first module, but we are going to move on to the next step, modeling the problem and recognizing the change in the problem. We will be using our virtual manipulatives to model the problems in this module, so if you have not yet taken the tutorial on how to use the virtual manipulatives, I suggest you stop this video now, go back to the pretest page and watch the tutorial first, then come back to this module. Here is an example of the objectives of this module as stated in the module introduction. Mary had 8 cupcakes. She gave 3 cupcakes to her friends. How many cupcakes does she have left? The important information is that she had 8 cupcakes and gave 3 away. After finding the important information, which you did last module too, you will then go on to modeling the problem and the change. In this example, 8 cupcakes were drawn, and then 3 of them were crossed out to show the change. Let's begin the lesson. Susie was bird watching in her backyard. She counted 8 birds in the tree. Then 3 more birds flew into the tree. How many birds does Susie see now? Since we have completed Module 1, we already have our sentence restating the word problem. Susie sees blank birds in the tree now. Now we have to identify the information in the problem that will help us find the answer as stated in the sentence. First, we see that Susie saw 8 birds in the tree first. Then 3 more birds flew into the tree. Now we know all the information the problem gives us in order to find out how many birds Susie counted. Let's go to the workspace now and try to model this problem. There are many ways which you can correctly model a problem, and I'm going to try to offer you different ideas throughout this module. For this problem, let's use connecting cubes. Make sure you use all the information you found as important in the problem when modeling it. Susie saw 8 birds first, so I'm going to pull over 8 cubes to represent those birds. All right. Next, we know 3 more birds flew into the tree. You have to ask yourself what that means. If more birds flew into the tree, are we going to add cubes or take away cubes? We are going to add cubes because we are counting the total number of birds Susie saw. 1, 2, 3. There we are. We have modeled our first problem and shown the change in the problem. Let's move on. Mark loves to collect rocks. He has 9 rocks in his collection. On a trip, he found 6 more rocks. How many rocks are in Mark's collection now? What is the important information in this problem that we need to solve it? We are looking for all the rocks in Mark's collection, as stated in the sentence. So we need to know that he already has 9 rocks in his collection, as explained here. Then we need to know that he found 6 more. Check over the problem and be sure you have found all the important information. Once you are sure, you can begin to create your model. First, we are going to show the rocks we know Mark had to start with. The problem tells us he has 9 rocks. We could use the cubes again, but let's try something different. I'm going to draw a model this time, and just draw some circles to represent the rocks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whatever method you choose, you must make sure you count carefully, as you wouldn't want to mess up your problem just because you didn't draw the right number of objects. Now then, I have to think about the next piece of information. He found 6 more rocks. If he found the rocks, is he adding them to his collection or taking them away? Right, he's adding them. So I'm going to draw more rocks in the picture. 1, 2, 3, 4, 5, 6. There we go. An appropriate model to show the change in this problem. The 9 rocks he had and the 6 rocks he found. Let's keep going. Sal had 15 cookies in his book bag. He gave some cookies away at lunch. He has 6 left. How many cookies did Sal give away? Sal gave blank cookies away. This problem gives information in a different way, doesn't it? But we still have to figure out how to use it to model the change. First, we know that Sal had 15 cookies. Then, he gave some away, which is the number we're looking for. Last, we read that he had 6 cookies left. How can we correctly model this problem? Well, let's start with the easy part. We know he started out with 15 cookies. With this problem, I'm going to draw, but instead of drawing 15 cookies, I'm going to use a part-part-whole model, which is a very useful model when we are looking for a missing part, like in this problem. To draw a part-part-whole model, first you draw a big box. And it doesn't have to be perfect, of course. This big box represents the whole. The whole, of course, is whatever the entire amount is. In this case, it's 15, or the number of cookies Sal had to begin with. I show that by writing the number on top of the box like this. Now I'm going to divide up the box into as many parts as I need. In this problem, I only need 2 parts. 1 part for the cookies he gave away, and 1 part for the cookies he still has. I know that he had 6 cookies left, so I'll write that in 1 part. The other part, the cookies he gave away, I don't know, so I can leave that part empty or draw a little question mark in it. Always make sure you check your problem as you work so that you know you have used all the important information and used it the correct way. This problem is now modeled correctly. We can see that the change is a missing part, the number of cookies Sal gave away. Mary and Jack are in the same class. Mary read 7 books this week. Jack read 5 books. How many more books did Mary read than Jack? Mary read blank more books than Jack read. This kind of problem has always been a little tricky for first graders like you, so I'm going to show you a great way to model it correctly so it can't fool you anymore. As mentioned in the first module, catching these words more than in the question is a big hint for that you are comparing amounts. We have to go back to the problem and find the amounts we are comparing. In this problem, we are comparing 2 amounts. The amount of books that Mary read, 7, to the amount of books that Jack read, 5. Let's use the counting cubes again for this problem, so I can be sure my objects are all the same size, and it will make the model easier to see. Before I grab any, though, I'm going to write down Mary and Jack's names on top of each other, like this. All right. I want them side by side like this because we are comparing them. Now I'm going to use the cubes to show how many books each of them read, and I'm going to put them in a nice little row beside their names. Mary read 7 books, so I'm going to put 7 cubes. 1, 2, 3, 4, 5, 6, 7. Move those over a little bit so they're all in the window. It's kind of nifty as you can actually connect them. See? Now they're actually connected. But all right. Jack read 5 books. 1, 2, 3, 4, 5. All right. Now, to show that I am comparing how many more books Mary has than Jack, which is the change in this problem, I'm going to pair up the books, 1 book from Mary to 1 book from Jack, using the pen tool until I run out of books to match. 1 to 1, 1 to 1, 1 to 1, 1 to 1, and 1 to 1. Now there are no more books from Jack that I can match with Mary. So now I can see clearly the number of books that do not have a match, which accurately represents the problem. Now it's your turn to try. Tom counted 8 blocks on the floor of his room. Then he found 4 more under his bed. He put all the blocks away. How many blocks did Tom put away? Tom put blank blocks away. Now that you have heard the problem, find the important information and use your virtual manipulatives to model the problem. Pause the video now to work. Press play when you are ready to check. Welcome back. I trust you now have a great looking model. Let's see if you are on the right track. First, I hope you picked out the important information. That Tom counted 8 blocks on the floor and 4 more blocks under the bed. Let's look at the different things you might have done. You might have used connecting cubes like this. 8 cubes to show the blocks on the floor and 4 more to show the blocks under the bed. Since the problem tells us Tom put away all the blocks he found, we know we have to count all the blocks, which means putting them together. You might have drawn the problem like this. You would still have a group of 8 and a group of 4 to show that they are being put together. Last, you could have used a part-part-whole model. In this model, you know both parts, but not the whole. So the model would look like this, with each part filled in, but the whole is left blank. Do you have a model like one of mine? Good job! Let's move on to the next problem. Jan had 12 new pencils. She gave a few to her friend. Now she has 8 pencils. How many pencils did she give to her friend? Jan gave blank pencils to her friend. Now that you have heard the problem, find the important information and use your virtual manipulatives to model the problem. Pause the video now to work. Press play when you are ready to check. Welcome back. I bet you have another good-looking model to share with me. Did you find the important information that I did? Click. I hope so. Now let's look at the possible models. I hope you found the information that she had 12 pencils. She gave some to her friend, and she has 6 pencils now. You could have used cubes like this. I got out 12 cubes to show the pencils Jan had to begin with. Then I circled 8 of them to show the ones that she had after she gave away some. Since I don't know how many she gave away, this is the best way to show that some change has occurred. You might have drawn a picture like this. I drew 12 sticks to represent pencils and, like the cube model, circled the 8 she had left to show the change. Last, you could have used a part-part-whole model, where 12 is the whole, 8 is one part, and the pencil she gave away is the unknown part. Do you have a model that looks close to one of mine? Good! As long as your model shows 12 objects, with 8 of them grouped off somehow, you have correctly modeled the problem. Let's keep it moving. John had 8 fish in his tank at home. For his birthday, he was given 3 more fish. After adding them to his tank, how many fish does he have now? Now that you have heard the problem, find the important information and use your virtual manipulatives to model the problem. Pause the video now to work. Press play when you are ready to check. Welcome back. Let's compare our work. Here's the information you should have found. He had 8 fish, and then he was given 3 new fish. Now let's look at the models you could have created. Just like before, you could have used cubes, pictures, or a part-part-whole model to show the problem. In each problem, we see that there are 2 parts, the 8 fish that John had to begin with, the 3 fish that were given to him to add to them. If your model is close to one of these models, showing that 2 parts are being added together, you are on the right track. Let's try one last problem. Sam and Todd got new crayons. Sam had a box of 12 crayons. Todd had a box of 8 crayons. How many more crayons does Sam have than Todd? Now that you have heard the problem, find the important information and use your virtual manipulatives to model the problem. Pause the video now to work. Press play when you are ready to check. Welcome back. Here is that tricky comparing problem again. Remember how I showed you to model it? Let's check first and see if we found the same important information. Sam had a box of 12 crayons. You should have also found that Todd had a box of 8 crayons. Now let's see if you remembered how to model this special kind of comparing problem. You could have used cubes or drawings. As I mentioned before, it's my personal preference to use cubes, and in this case you can see I switched to the base 10 blocks because the connecting cubes were too big for me to make a row of 12. The cubes are a lot easier to line up, but it's really up to you as long as you're careful. In each model, the cubes and the drawings, you can see I laid out the crayons that Sam had and the crayons that Todd had. Then I matched them 1 to 1 until I ran out of crayons to match. This is the best way to model this type of problem. I hope you remember to use this special comparing model too. Wow, you did a great job modeling these problems. If you want to go through this video again, please do so as many times as you need to. Or go to the practice quiz section of this module and practice what you learned before taking the official quiz. Good luck!